Right, we have a few of us in. Well, I'd just like to welcome everybody who's just joined us on YouTube for this historic day. I do have a stream running, but unfortunately, we can't do a live stream direct from NASA or from YouTube. So when we do go to the launch, we will need to mute our microphones. The qualities are probably about 80% rather than 100%. So what I would recommend is if you would kindly stream on another, like a pad or another computer, or even on your TV if you're able, with it the sound turned down. And then when we move towards the launch, then we can watch it on the Zoom here, and also on your other pad for a clearer picture. Also, Zoom decides that it wants to cut down all the background noise. So if you watch it on here, you will have a very quiet launch. For some unknown reason, it thinks that rocket sound is nuisance background noise, and it cuts it out. I see Andy's joined us. Welcome back, Andy, and Lou, and Rachel. How did your trip go?
Very well, thank you. Got back a little while ago. I was at the Astronomy Island Barbecue giving a talk there, and the whole event went off like clockwork. It was hugely enjoyable. I was faced with an audience of 600 people, and everything went absolutely beautifully. Excellent. And there were 90 children there, and they got to launch some rockets. They got to do lots of science experiments with a guy called Mark, the science guy, who was teaching them all about rocket propulsion and letting them do things. And it was hugely enjoyable, and the whole event was a massive success. So,
oh, excellent! That's fantastic.
Yeah, well done.
Yeah. As long as none of the children came up and called you dad. Right. It's been a year or so since you were last there.
We had a little boy in the audience whose birthday it was. I think it was about 10.
Oh, excellent.
And I got all 600 people to sing happy birthday to him.
Oh, that made his day, no doubt.
Apparently he was highly embarrassed, but confessed later that he loved it and he'd never forget it. So that was worth it.
And welcome, Lou, from America. It's lovely to see you. Of course, it's morning for you, but it's the afternoon for us.
A bit earlier.
And I'm glad we could do something for this historic day. Unfortunately, at the moment, they're holding at T-40 because they've got some issues with, I think it's engine 3, and they've got a couple of niggly hydrogen leaks, which they just want to check over and make sure everything's safe, which, of course, we all want. Because this is the launch of the SLS, the Space Launch System, and the Orion capsule, which of course this is on the part of the Artemis 1 program, which is the very start of sending humans back to the moon. This is the first test flight of all the systems integrated together, and it's going to go out around the moon. It's going to spend quite a long time there, actually. It's about 2 weeks, orbiting the moon, and the whole mission is approximately 42 days. So looking forward to it, Lou?
Absolutely. I'm part of, I guess, a group getting a little bit smaller each day that remembers where I was with the first human launch to the moon in 1969. And, space flight, no matter how you cut it, is a hugely complex endeavor. And I know there are people, some of our viewers were frustrated that, it comes out to the launch pad, they find some problems, they bring it back, and things get delayed. But that's what happens when you're exploring new frontiers.
Exactly. This is, if it was easy, everybody would be doing it. So as well said, this is a test flight. This is to test everything. They've also got some mannequins on board, which are going to be testing. They're wearing special vests, and the radiation levels that they're going to be exposed. Well, the humans, when they go into space, will be exposed to for these duration flights. They're just testing to see what people are on. There's also other things. There's Cubesats, which we can all talk about a little bit later. And it is a test system. And
I they have over 1,000 sensors
yeah.
on the spacecraft, so they're looking at everything to make sure it's right for human space travel.
Yeah, and we just got our fingers crossed that we waited so long for this, and we just can get this thing off the ground. But if it doesn't go today, of course, they've got another launch window later in the week. So hopefully we will see. If we don't see anything today, hopefully I think they've got chances on the 2nd and the 3rd, and of this week. So, but let's get it up there today. Let's see some. Let's fingers crossed. Let's all be positive. Let's all be positive. Pray to you, whatever God you pray to Sol, pray to the moon, pray to anyone. Let's get the thing off the ground. Sure. And I'd just like to say hello to Rachel. It's lovely to see you. So what are you looking forward to, if anything, for this?
Just being part of it and learning things. I've never really been up to scratch on any sort of, I don't know a lot about missions or being voyages. I don't know a lot about that sort of area of space and astronomy news. So I think just being here with you guys and listening and watching and hopefully seeing a successful launch, but yeah, just enjoying it and learning along with you fine, knowledgeable people.
Yes, of course, you're our what can I say? You didn't experience the Apollo. We're all Apollo veterans. We can all remember where we were, and of course, you were just a glint in Daddy's eye. So, but yes, this will be your first moon mission, I presume. So, yes, it's we're now entering. I mean, people talk about the Apollo years, but now we're entering, hopefully, the Artemis years, and we're going to get this sorted, and we're going to get it up into the air. And we're going to go back to the moon. I mean, to be quite honest, I'm quite excited, actually.
Yeah, me too. It's funny how your brain plays tricks with you, though. I have clear recollections of watching, I think the earliest Apollo launch I remember is Apollo 7. And I have clear recollection of watching them all in color on the television. And I was thinking the other day, that couldn't have been because we didn't have color television then. So I must have got my memories from seeing color films later, but I could swear that we watched it in color. But it was such an amazing era for humans. It was a time of optimism that we could do anything. We could go to the moon and we could go anywhere and we could do anything when we worked together as a species. And I think for just a brief moment in time with Apollo, humans did really feel like they were humans and not black, whites, Christian, Muslim. We came together as humans first and foremost, and I think that's the only time in history it's ever really happened.
Yeah,
and sadly, it didn't last.
Yeah, I mean, space does seem to draw people together.
Oh, it definitely.
I mean, even with the troubles we've got at the moment in Ukraine, Russia and the US are still working together on the International Space Station. They've all got to work together. There's also going to be, I think there's an American launching from Russian soil very soon, and then there's also a Russian lady launching in the on SpaceX to go to the International Space Station.
Sure.
So unity is what we're all looking for, and of course, when we do finally go to the moon and we actually land, there is of course the added bonus that it will actually put the first woman on the moon, and also the first person of color. It's a shame that we have to emphasize these things because it should be the norm. It should be the norm. There shouldn't be any of this sort of having to specify what these things are. It's going to be a fantastic achievement. And I mean, we've still got a long way to go before we actually land on the moon. But this is the beginning, and fingers crossed that everything works. And as I said, we just for anybody who's just joined us, we are holding at T minus 40. So I don't think we got any questions in the chat just yet. So yes, so I mean, I don't know. It seems very. I mean, we've had some holds, or there was even a threat of possibly a scrub during the night. I mean, I've been up most of the night, just sort of like, watching, yeah, watching most of the
dedication.
Yeah,
and
that's
then
dedication for you.
and then we, well, the thing is, I was a bit worried about actually watching the fueling take place, and then of course then we had the threat of a leak, and there was talk of scrubbing it and things like that, and you just, oh no. Then of course I was also on tender hooks with that, and then of course they sort of like working around it, and they've started fueling again. They've even fueled the top upper sections to try and catch up one a bit at the time, which they wouldn't have done by now. Well, they would have started it by now, but they started it early to try and catch up on some of the time. They're finding some niggly faults. This is why we've got the hold. And then, of course, I was a bit worried that if I go to bed, I'm not going to get up in time to set everything up for this event. And as I said, I've got it streaming. As I said, the quality is not that fantastic. So if you can have it streaming on a separate object like a TV or another computer or even a pad, just for the launch and all that. As I said, there's no way I can work to get any sound because Zoom's noise suppression system is so great that they think it's rocket launches or rocket sound is total interference, and it cuts it totally out. So we'll be watching it on Zoom in silence, but if you've got it on another device, you can turn it up and listen to it. And I just think it's going to make a bit of a racket. So it's not going to be like one of these electric cars where it goes bing, bing, bing. This is going to take off and it's going to fly and it's going to go with a real roar. So I hope everyone's looking forward to it. So has anyone got anything to say?
I was going back to what Andy said. I'm not sure how new it is, or maybe if I've only just found out about it, but my friend sent me a link the other day to somebody who's sort of going through all the footage and like the archive stuff from Apollo and the moon landing and sort of reprocessing all the images.
Yeah.
And the differences, like I was looking through them and it feels like you're seeing them new, like brand new again. Because the quality was so good. And I guess now we can, up level these images, but I think that doesn't help your memories when you're seeing all of these fresh things sort of being updated to current technology, and then you're inserting them into your past memories.
Absolutely. I mean, in terms of the images that they took during the missions, we have the fantastic Hasselblad cameras to thank for that, which produce stunning images. And of course, in those days, watching them on 625 line TV did not do them justice. And I remember when my dad got me out of my bed at 6 a.m. or something to watch Neil Armstrong place his foot on the moon, and you've all seen it. I mean, the ghostly images that we were getting back from the moon, and then you look at just a few missions in. By the time Apollo 14, 15, the TV images had improved immeasurably.
Yeah.
And by the time Apollo 17 came, they were really, really good. But it was a totally different world in terms of technology. And what we can do today with imaging, of course, would have been pure science fiction then. So
that's probably why kids are almost desensitized to it today, which is probably why we have to work harder in some senses to get them excited, because they're spoiled for choice with sort of manipulation on movies, and they're seeing all of these animated and up-to-date things. I think it's hard now because a lot of people are used to seeing images, whether they are real or fabricated. And I think that's why we have to work harder to get people just looking through eyepieces and saying, look at the actual things now, because this is what's happening. And
Yeah.
Well, space travel is becoming rather commonplace. That's good news. That's good news. And we talk about this as being our first inroad back to the moon in a long time, and that is true in a sense. But remember, this is a dual mission. This is an engineering mission to make sure the spacecraft is working and all systems are A-OK. And it's also a science mission, right? And so we've been going back to the moon robotically for lunar science for quite some time, which had some of its beginnings in a program called RLEP, right? The Robotic Lunar Exploration Program. And the LRO spacecraft, which is orbiting the moon now, the Lunar Reconnaissance Orbiter, was the first, what was planned to be 4 spacecraft to orbit the moon and find out what it's made of and what the conditions are and how the radiation levels go and so on, in preparation for going back to the moon. So we've actually been going back to the moon in a sense for quite a while, but this is the first one that is kind of billed as a preparation or a dry run, let's say it that way, for humans.
And the number of articles in the media and the number of videos on YouTube saying, NASA returns to the moon after 50 years. And I've been saying, no. This is not NASA's first return to the moon after 50 years. It's the first attempt. It's the dry run for the first attempt at putting humans back on the moon. But as you say, we've been investigating the moon robotically for a long time, and not just America either. China has as well.
Right.
So this is not NASA's first return to the moon since Apollo, but it certainly is the biggest, most powerful rocket ever made sent to the moon. This should be an amazing event. Any updates there, Daz, on the Engine 3 situation?
Not at the moment. We're still running at. We're still on hold.
Still on hold.
And of course, when you were talking about the moon, of course, Israel unfortunately had a mishap with their probe that they sent to the moon, and they've distributed hundreds of tardigrades all over the surface.
Yes.
And these little blighters, they're so hardy that people were not concerned, but were wondering whether or not they survived. I mean, these tardigrades have been exposed to space radiation, and a few of them passed away, but others were revived because they go into this state of dehydrated sort of like sleep, hibernation, in which they can exist for years, and then just revive when the circumstances are correct for them. And they're called what we call extremophiles. So we could have a moon absolutely swarming with tardigrades who were a little bit annoyed, a little bit annoyed that we left them there and didn't come and rescue them. So revenge will be sweet.
I would be a little skeptical that they would survive that long in a high radiation environment. I know they're hardy, but I don't think they're quite that hard.
Because they did speculate that they wouldn't survive the impact, but then somebody put a load in some bullets and fired them at a brick wall, and lo and behold, a lot of them did survive.
Yes.
They are the thing. But yes, as you said, they've been irradiated all this time. It's been a few years now, so it's a shame because I love the little blighters. You can find them everywhere around the world, even on the seafloor. They're absolutely everywhere, and they're fantastic little beasties, and they're really well. This is why they're used for experimentation and exposure to space conditions. So but that's by the side. But
we don't usually think of the moon as part of our exploration for habitable worlds, right? But as we look at the Earth and we find, as you're saying, that these extremophiles who live in high radiation environments, highly acidic lakes, or hot ocean vents, these kinds of things, then we have to expand our understanding of the conditions for life that we might find further outside the Earth, right? So it's really the exploration of our own Earth that gives us clues as to what life might be like, or the environments that life might be able to exist in outside the Earth.
Exactly, because this is why we really, well, for me personally, I'd love to go to the ice moons with the oceans underneath the ice, and you know, there's a good chance that hopefully something has become about from what the conditions that are there. But until we get out to the ice, I mean, we've got some probes going out. We got Europa Clipper. We got Juice. Already there is Juno having a look, but that's not designed to do any sort of like tests or anything for in the plumes or anything like that.
Don't forget Dragonfly out to
the
Dragonfly,
yeah, that's
Titan.
right, yeah, the little well, not the little helicopter, it's quite a big one. Whereas on Mars we had Ingenuity, which was a small craft with massive wings because of the atmosphere is so thin. Titan's the other way around. It's got quite a thick atmosphere, and it's the size of a small car, if I remember right. And it's got quite small blades because it will be able to fly quite easily in the thicker atmosphere. So, and again, you know, that's a totally different world. So yes, it's something really to look forward to.
And beyond Dragonfly, there are plans to drop a submarine into the lakes of, or one of the lakes of Titan, and that would be just truly amazing to actually go underneath.
Yeah,
who knows what we might find in that alien that harsh alien environment. But again, we find life in harsh environments here on Earth. So
I don't know whether I told you. I don't know whether I told you, but one scientist has come up with a, if you like, designed for a creature that could live on Titan, that uses you know, the hydrocarbons, liquid methane, liquid ethane, and so on, instead of water. And he designed it on a computer, and he says it's viable. It could actually work. So that's quite interesting.
Yeah, it was some strange creatures, weren't they? That
really weird looking things. But you know, he says it's not impossible that life could evolve in that sort of environment, and using the hydrocarbons instead of water as a liquid.
Anybody who's ever seen a weed grow out of a sidewalk knows that life wants to exist.
Yes, absolutely.
Because also we've got our probes going. Well, we will be going out to Venus to check on this phosphine situation that keeps appearing and then disappearing. I don't know if they're not sure whether it's seasonal or whether it's volcanic. But of course, phosphine isn't easy to make, and this is why. But it can be found in the excrement of penguins. Hence that. Andy's coming up.
Don't start rumors that there are penguins on Venus.
Well, Andy's writing a paper. He's convinced.
I'm halfway through writing my paper about penguins in the atmosphere of Venus. Don't give me bad press before I even have to look at peer reviews, for God's sake. Of course, there are penguins in the atmosphere of Venus. Where else do you think the phosphine comes from?
But yes, we were joking apart. We've got our probes going out there. There's 3 at least that I can remember. Veritas, I can't remember the other 2 now. One's European and 2 are NASA based. But there's a lot to look forward to. There's a lot more exploration, and of course, really, we must mention also that the SLS is also the first stepping stone in possibly moving on to Mars. This is sort of like the planned vision. Get a foothold onto the moon, find out about habitation and living in these environments, and then eventually moving on to explore Mars with feet on the ground, which would be a marvelous thing to do. But Yeah, but of course we still need to get the samples back from Mars to see really what we would want to really look at. But of course, I think that we're getting pushed back now. I think it's to 2033 now. They think we'll
Something
get the
like that.
samples.
Yeah. Yeah.
Which is
It's always
unfortunate.
20 years away or so.
Yeah. So, but like I said, this is the first stepping stone. This is to get ourselves back out into the onto the moon and then move on, hopefully, to Mars. And there's some big plans that they've got for these machines.
I personally think that SpaceX will get to Mars and retrieve samples before the ones from Endurance get back, because I think once Starship is certified for human flight, and that's still a few years away yet, I guess. Elon Musk is going to take the next opportunity to go to Mars, because Starship has been designed for the job, really, and it can carry a lot of cargo to Mars. So we'll have to wait and see. But I think the next 5 years are going to be really interesting to see what happens, both with Artemis and with SpaceX. And of course, don't forget that SpaceX is part of Artemis with the lunar lander, because SpaceX are building the lander to land humans on the moon, and the lunar version of the Starship, the lunar variant, so-called. And they're working on that at the moment. And because it can carry basically 100 tons of cargo at a time, setting up a moon base, a permanent moon base, is going to be, a lot easier because of its sheer capacity. So we've got exciting times ahead, that's for sure. So I see that we're still. Oh, have we moved off the hold now? Can't see the hold.
No, we're still on the
Still on the hold, right?
One thing I will tell you, which is very strange, is that the link I've got on the Zoom is 9 seconds advanced from what we've actually got on YouTube. And I think it must be due to the device I'm using, because I'm actually streaming a YouTube link here.
Right. Are you sure you put enough water in the kettle, Daz?
Well, I don't know. No, for this computer, you mean? Get the steam
yeah. Because we know it takes days for your computer to build up a head of steam.
Oh, every time it does it, every time it does an update, that's it. I'm out with a link loop for weeks.
Yeah.
They're just showing some more outside shots, and you can see some of the condensation that's formed on the spacecraft itself. But yeah, it's we're still on hold. I mean, I think they're still having trouble cooling down. I think it's engine number 3. They said it was.
Yes, it is. Yes.
And there are some more minor leaks that they got.
And this engine chill operation, of course, was the one that they couldn't test earlier in the year because of the problems that they had with the hydrogen leaks. So they're doing this really live, if you like, for the first time, chilling these engines down, and it's worked for 3 of them. But there's always one, isn't there? And we know from past experience, holds are nothing new. And it's a brand new rocket, for goodness sake.
I mean, we've got a 2-hour launch window, which opened at 1:30, which opens at 1:33.
Right.
But of course, we won't be going then. But there was also a designed 30-minute hold, which really isn't necessary, but they just wanted to hold and check all the systems at T-minus 10 minutes. They were going to go on to a 30-minute hold.
Right.
And
Hey
then,
guys, I'm sorry to interrupt, but I see our guest speakers having a little trouble getting in, so I'm gonna opt out for a minute or so and see if I can give them some.
Right. Thanks, Lou.
Okay. Thanks, Lou. Yeah. So they got a T-minute minus 10-minute hold for 30 minutes. But of course, if they think that they don't need that, they could cut that out. But I think it will be a late launch anyway, regardless, because of the problems they've had before. Yeah, it's like I said, I was sat here and then they were talking about, there was talks about scrubs going on. I think, oh no, here we go. But as we said, but this is what it's all about. It's all about testing the systems, making sure everything's correct. There's no point in going off half-cocked, because you're just going to have problems later down the line if you're not careful. Sorry, mate, Andy.
Yeah, I was going to say, and of course, it's not just the rocket; it's all the ground support systems.
Yeah,
it's all of the software that has to run perfectly. These are immensely complicated machines, and it's not just a matter of lighting the blue touch paper and running away. There are thousands and thousands of operations involved in launching a rocket this size, and every one of which has to go perfectly.
Yeah.
And
all these systems have to work, as you said.
Yes, absolutely. We saw with the James Webb Space Telescope that how complicated these things can be, with multiple possible points of failure. And in the case, how many was it with the James Webb Telescope? Hundreds, literally hundreds of things that could have gone wrong at any time, but everything worked perfectly, which was amazing.
Yeah.
But that is not the same as what NASA are attempting today.
Yeah. I'm just like to point out that our best to tell people where we actually are.
Okay.
We're actually at the Kennedy Space Center, and we're on launch pad 39B. This is where this is happening today. I'll just give you a quick. As we said, we were hoping that the launch windows opens at 1:33 UK time, which is 8:33 EDT. And when this thing does go, there are a few things to look out for during the actual launch. From the actual launch, 2 minutes 10 seconds in, you will see the solid rocket boosters separate, and these will splash down into the Atlantic, but they're non-retrievable. After about 8 minutes, we will see main engine cutoffs, and then the first stage will separate. So we'll lose. Right, sorry, I've just got to let somebody in, our guest. So 8 minutes in, we'll see the separation of the booster section. Then 51 minutes after liftoff, the interim cryogenic propulsion stage will do a brief burn, which will raise the orbit perigee. And this is basically just to push it up into a higher orbit. And then 1 hour, 37 minutes after liftoff, there will be a trans-lunar injection burn, which is due to last about 18 minutes long. And this will push the Orion space capsule towards the moon. It will be able to escape the Earth's gravity, and it will separate from the interim cryogen propulsion system. I'd just like to stop there and just say hello to David. Nice to meet you. It's lovely of you to come along.
How are you, Dave? Lou, would you like to introduce our guest?
Yes, absolutely. Well, we're very fortunate today to have Dr. Dave Williams on the show. I've known Dave for longer than I want to admit, working together at NASA Goddard Space Flight Center, where Dave is a planetary scientist who's in charge of the Space Science Data Coordinated Archive, the NSSDCA. Right. Archives all of the data from space missions. Well, maybe it's not all. I don't know. It's a bit complicated, but Dave is also a part of the planetary data system at NASA Goddard, and he's has his PhD in geophysics and space physics from University of California at Los Angeles. Just reading your bio here, Dave.
Yeah, okay.
And Dave has some interesting stories to tell. He's about moon trees, among other things, among his other claims to fame. So welcome, Dave. Thanks so much for being here early in the morning on the East Coast.
Yeah, I am sorry I'm a little bit late. I'll tell you about this later because this is kind of cool. I also just got an email this morning. But you mentioned about the moon trees, that they're not sending the moon tree seeds on this mission. So somehow
really?
that didn't
Oh.
work out. So
Oh, that's a
anyway,
shame.
They're just seeds.
yeah, it was.
Yeah.
Well, they were going to send, right. They were going to send a bunch of They did this on Apollo 14. I don't know how familiar you guys are. And I don't know how much you want me talking before the launch either. But on Apollo 14,
Carry on.
right. I won't talk through the launch, I promise. No, on Apollo 14, they Stuart Russo, who was the command module pilot, had worked for the Forest Service and brought a bunch of tree seeds with him in his personal preference kit. So while everyone's brought coins and stamps and little memorabilia and photographs, he brought tree seeds. And when they got back, gave them to the Forest Service, they germinated these and they grew these little saplings, and then they sent them around the country in 1976, and they planted them all over the place for the bicentennial. And then the story just kind of got lost. So it got picked up again when I heard from a third grade teacher whose class was doing a project on trees and asked me about this one tree that had a little sign on it that said a moon tree. And I never heard of these things at all, but it was such an interesting story that I put it up online, what I had found at least. And I started getting people emailing me, oh yeah, we have a moon tree here, and we have a sign, a tree that says it's a moon tree. And I remember planting a moon tree. And so all of a sudden this whole story came together. So anyway, they were going to try to send the exact same types of seeds on this mission. And I guess they didn't quite make it. This is, like I said, I just heard this morning. I didn't realize until this morning that they weren't going to. And anyway, I assume that they're prepared for, a later mission. I mean, it's not something that, weighs anything or takes up much space. It's you can put hundreds of tree seeds in, nothing. So anyway, that's the moon trees. So anyway, you were talking about the launch, and I don't want to interrupt you too much.
What are you most looking forward to seeing today, Dave?
For me, the Cubesats. I mean, there's 10 Cubesats that are in the adapter ring that are launching, and they're all sorts of all sorts of different things.
Yeah.
That they're doing. There's a bunch of lunar missions. There's a bunch of tests. There's actually a little tiny mini solar sail mission. And also a Japanese mission that is actually a tiny CubeSat that's going to try to land on the moon. It's what they call a semi-hard landing. It's got a little retro motor in it. It's got airbags, and it's got epoxy hardened components, I guess. And they're going to see if they can smash into the moon at 50 to 100 meters a second and survive it. Anyway, so there's all sorts of really exciting things, and they'll be like popping these out as they go, depending on where these different satellites are supposed to go. Some are going into orbit around the moon, some are going off into deep space. But
sure.
Yeah, to me that's kind of the most exciting part of this mission.
Yeah,
and of course the CubeSats are another thing that just didn't exist during the Apollo years. They would have been absolutely in awe of the fact that we're now building these tiny little satellites that are so capable and do so much.
Yeah,
I agree. I also think it's a really exciting, like the paradigm of the CubeSats a little bit reminds me of the early Ranger surveyors, the early satellites that NASA was launching, because they accepted a failure rate on those.
Yes.
I mean, they were, if it didn't make it, if the satellite stopped working, if it whatever, it was okay. We can accept 20-30% failure rate on these things because we're just learning. And the CubeSats now, I think we're getting that again, and I think that's not a bad thing. In other words, let's send up stuff. Let's see what works. Let's find out, and it's not breaking the budget because these things aren't so expensive. So I'm kind of excited about the new paradigm as well.
Yeah, of course, because the little CubeSat that's got the wind sail or the solar sail is due to go off to an asteroid, isn't it? If I remember rightly.
Yes.
And also we've got to remember that we've already got a CubeSat which is doing a little bit of exploratory work. In fact, it's still on its way there. In fact, the SLS or the Orion will get there before it does, because it's not due to get there till the end of November, December. And of course, that's Capstone.
Yes.
And that's going to be hopefully entering orbit around the moon, which is what the Lunar Gateway orbit will be using to check stability and things like that to make sure it works. So yeah,
Right.
there's a lots of science going on. There's a couple of mannequins on board checking radiation levels, what are the effect and the effectiveness of vests that are to reduce radiation that the astronauts. There's a lot going on. Really, is a lot going on this. As Lou said, it's a scientific mission as well as a step towards us actually putting feet back on the moon in a few years' time. And for some unknown reason, on the stream, I've got a helicopter. I didn't think we were sending helicopters, but there you go.
That's our backup. That's the backup plan.
Yeah, but
And Dave, you were mentioning the Japanese. What did you call it? A soft crash?
Semi-hard landing.
Semi-hard landing. And,
Yeah.
and our very, very first robotic missions to the moon, weren't they kind of hard?
The Rangers were just like not even
Rain-
semi-hard. I mean, that's as hard as you could get.
Yeah.
they just
Yeah.
plowed straight in and took pictures up to the last second.
Yeah.
That's the easy way to do it. That's the
Well, yeah, it's sort of easy, but that's an example of what I was talking about. The first 6 Rangers failed. Now you can't even imagine nowadays, right? Some series of missions and the first 6 fails, they're going to shoot a 7th one. I mean, that's not happening, But with CubeSats, you can afford, maybe not 6 failures in a row, but that sort of thing, So even the Rangers, when they were doing it at that time, weren't that easy.
Absolutely.
Absolutely. I'd just like to welcome Roger. Hello, Roger. How are you? Now,
Not too bad. I've been following Everyday Astronaut with his chit chats.
Well, this is a gentleman, David, that is our resident moon photographer. He produces some excellent images of the moon virtually every night.
Stunning images.
Stunning images.
Actually, this morning, I gave up trying to image Jupiter, and I got rather a nice one of Mars this morning.
Oh, excellent.
Which I've posted up on
yes, I saw that.
Social media.
Yeah, and as you can see, David, he's bashful. So
Roger's friends with a higher power because he gets all the clear skies.
Yes.
Yeah, I don't know how he does it.
Well,
he's the anti-cloud magnet. That's
yeah.
It might be clear, but the seeing was absolutely atrocious for Jupiter. It was just so fluid. Looking at it, I just couldn't achieve focus. But with Mars being up so high at 4:15 this morning, it was really good.
Yeah,
and I managed to get the ISS to come over, so I've got a picture on social media.
You arranged that, did you? You arranged that, did you?
Yeah, I can do that.
See, you're definitely in touch with a higher power.
So I got Orion, Taurus, Mars, and the ISS all captured in one image.
Oh my God, is that all?
Tell me when you book the Aurora, Roger, and I'll come over.
Yeah, all right.
You're up at 4:00 this morning. Do I understand?
I did. I was up to about 2:00 this morning and gave up with the clouds because it was forecast to be clear. So I set the alarm and I got up at 4:00 and did some imaging through to about 6.
So we have a panel of experts who haven't slept, is basically.
Yeah, I was up at 4 this morning to get my flight back from Ireland. So
yeah, I was checking the route, the fueling, and things like that. So yeah,
I was hoping to get some sleep on the plane. I thought I've got 2 hours, just over 2 hours to get some sleep. And there was a baby behind me who cried for 2 hours solid, and I didn't get any sleep whatsoever. So I might start to talk nonsense. Well, more than normal anyway.
About the launch, no doubt.
Yeah, absolutely.
Yeah, this is dedication. This is this is what we do. And we'll fight through the tiredness. Plenty of coffee on the brew. But
I see that the vice presidents landed nearby about 5 minutes ago.
Oh, right.
Well, the helicopter.
In a helicopter. I think that's just a reporting helicopter. I think they landed elsewhere.
Well, we want him to clear off. We're not going to launch with that flying around, are we? So yeah, it's we're looking forward. We're still on a hold at 40 minutes. They're still looking at obviously the problems that they've got with engine number 3. plus a few other little hydrogen leaks. Of course, they had some of these little leaks appear when they did the wet rehearsal. But I can see there's condensation and that coming from the engine bay at this very moment. So hopefully they've resolved the situation.
We were saying on the last program, because I think NASA had just released the list of 13 possible landing regions towards the lunar South Pole, and I was looking into some of them, and that's very rough terrain. I mean, the landing will have to be, a precision landing, because it's very rough terrain indeed. Well, one thing I was going to ask, Dave, do you know if when Orion goes into its orbits around the moon, is it going to go into an equatorial orbit, or are they going to loop the poles and get some photos?
I'm not sure.
I just wondered if you knew.
Yeah, they're experimenting with some different types of orbit, I guess. Maybe one of you guys knows better. No, I'm not sure.
Right. Right. Because it would make sense if they flew over the poles at least a few times to get some good images. So I was just wondering if that was the plan.
Well, the Lunar Reconnaissance Orbiter, those images are unbelievable.
They're amazing.
So I mean, considering they have a much better idea what the terrain looks like than when they landed Apollo.
Yes, indeed.
Which is a little comforting, I think.
Yeah. Yes, I've been watching a TV series called For All Mankind, which is an alternate version of the alternate history of the American space program, where the Russians get to the moon first, and it's all about what might have happened if the Russians had beaten America to the moon. And there's a wonderful episode at Shackleton Crater, where one of the astronauts is spelunking down the side of Shackleton Crater into the dark to try and find ice, and the visuals are stunning. And you think, that's a stunning area. It's the images, if they do land near Shackleton Crater, are going to be absolutely unbelievable, because it's the contrast, isn't it? It's the bright sunlight and the jet black that makes it just unbelievably visually interesting. Yes, Daz.
In answer to your question, just reading here, it says Artemis 1 is the only mission of the Artemis programs planned to use the DRO once considered for the asteroid redirect mission and deep space gateway programs. I think it's basically what it's going into. It's going to a distant retrograde orbit.
Oh, right.
And it's not until Artemis 3, I think, where they're going to actually go into an orbit over the poles to give them a look at it. And of course, with 3, isn't that when we're actually going to do the landing? So they're going to have a look-see before they actually decide where they're actually going to go. Because of course, as you said, when we looked at those images, the South Pole is a very, very cratered region. Sorry, Roger. Oh, sorry. What did just pop up, Roger?
They've just changed the launch to T-1 hour 30 minutes.
1 hour 30.
1 hour 30. So
Right.
what time are we on now?
So that will make. I'm trying to work it out UK time. I shouldn't do.
Yeah,
So that's 10 or 20 past 3.
Like 2 o'clock.
Nearly 5 to 2. Yeah. So they'll be pushing, but they'll give them another 30 minutes. Of course, we've still got at T-10. There is a planned 10-minute hold.
Yeah.
But hopefully, if everything is resolved and things like that, they may reduce that.
Yes.
The one thing I do want to hear, and I hope they play it, because I'm using a NASA spaceflight stream. Is I want to hear the go no go poll. That will bring back so many memories of the Apollo.
Indeed. Yeah, it will, won't it?
And because there was one chap on there, I can't remember his name, but he used to get so excited that he used to shout "Go!" and he would all the rest of them say "Go." Go, 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 go. But he was a bit of a character. But yeah.
So while we're waiting, why don't we ask Dave the question we ask all our guests? Where did your interest in space originally come from, Dave? What sort of turned you onto it, as it were?
Oh my gosh. I had a poster on my wall when I was a kid of the solar system.
Oh yeah.
And I remember, I still have that actual poster. It's actually the background on my screen now.
Right.
Because, so I guess I've just always been interested in science. And then, well, of course, I grew up during the Apollo program.
Yes.
So that was one thing. I always read science fiction, especially the kind of space science fiction is always kind of my favorite. I saw 2001 when it came out.
Yes.
And Star Trek, of course, the original Star Treks. My friend and I would always watch the original Star Treks. So it was just I don't know. I grew up in that era, I guess. So I've always just been interested. It's hard to pick one thing.
So you're like us, basically.
Kind of the same.
Yeah, absolutely. Yeah. So same as all of us. Apollo era, 2001, Star Trek, all the usual things.
And Cosmos.
And Cosmos, of course. Let's not forget Cosmos.
Right. Oh, that's right. I of course, Carl Sagan and all of that. I also then. Well, the funny thing was then, but I first took physics when I first took it in high school, and I just fell in love with physics. And so I was going to be a physics major, and I got a little tired after a year or so of, frictionless things and massless things and blah, 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 all these perfect systems that you were learning about, which is of course how you kind of have to learn at first before.
Yeah.
But I've always well, first off, I always collected rocks all my life ever since I was a kid. So I always loved that. And I kind of wanted something a little more messy, I guess. It seemed like it wasn't really real, all the physics I was learning in a way. I mean, not well, I guess maybe you know what I'm saying. Anyway, I found out they had a geophysics program at Binghamton University in New York, where I was going to school. And I thought, you know what, this sounds way more fun and kind of, like I say, messy, I guess. I don't know. So I went into geophysics and kind of, just never looked back, I guess. So yeah, that's kind of how I ended up here. I actually took the job at NASA just as something to do while I was looking for a real job. And I had always planned to teach, nothing big. I wasn't planning to do any high-powered, stuff, but I wanted to teach at maybe a small university or college. And that was kind of what I wanted. But when I finished up, at the time I finished up, and all my colleagues, all my friends at the same level as me, we were all saying the same thing. There were no jobs. I'd apply for a job at a place I never even heard of, some small college in the middle of nowhere, and they say, "Oh, thank you. You're one of 200 applicants for this for this job." So I said, "All right, you know what I need to do? I need to find something." I was working as a postdoc, but the time was running out on that, and I needed to do something. I saw this job for NASA. Oh, the NASA, it's a planetary scientist, archiving, blah, blah, blah. And I was like, that sounds kind of boring, but you know what? It's here. I lived in Maryland. It was here at Goddard Space Flight Center. It was planetary. And I figured, well, I can do that. I could probably do this for a few years. I can stand it for a few years. And then, then maybe the job market will open up as far as professorships. So I took the job and, I fell in love with it. I mean, I just loved the job. I loved Goddard. I loved it. One thing I thought was being in a college or a university, you have a campus, a life, and there's talks and there's people, it just seemed so, so fascinating. And then I found out Goddard was pretty much like that. It was kind of the same. It was really the same, except without the students, but it was the same kind of atmosphere. And the job I've just been fascinated ever since I started. So yeah, that's where, that's basically how I got where I am.
And what have you enjoyed most in your career?
Wow. We're restoring a lot of the Apollo data, the old Apollo data. The Apollo astronauts left these ALSEP instruments on the moon.
Yes.
And they returned data for, 5 to 8 years, depending on which mission. They turned them all off in 1977, but they were returning data continuously, long after the astronauts left. And a lot of those were never really looked at. They were, well, they ran out of money for one thing. The Apollo program got canceled pretty abruptly.
Yeah.
So all of a sudden there wasn't a lot of money for research after that. And meanwhile, these data were still coming back, but everyone kind of moved on. And I think there was a feeling that after a year or two of data from the moon, the moon wasn't doing that much. We've looked at the data. I'm not going to look at another 2 years of this data. It's going to be the exact same, and that sort of idea. So anyway, those data kind of have been sitting and going unlooked at. But then over the years, of course, the formats have kind of expired. I mean, basically, they're not readable in today's format. So we've been trying to restore them and put them back into what can be used now. In other words, well, basically, first off, putting them in ASCII, and then putting them into validated formats that and giving them to PDS, the planetary data system, and then the planetary data system can distribute them. So that's been one of the most fun parts. The moon trees certainly turned out to be fun. That was unexpected.
Yes.
That's been a little cottage industry, I guess, for me. And then there's a lot of other things. When we first started, it was right at the beginning of, well, actually, it was even before. When I first started, it was just about a year or so before this weird World Wide Web thing kind of came along. And we had one guy who was telling us about this. Oh, he goes, you got to see this. There's this thing called HTML format, and it does this and that and the other thing. And we, he started giving us demonstrations. And I remember like 1992, 93, he was showing us this, and I was thinking, oh, this is pretty cool. I bet maybe in like 10 years or so, this might actually be something that people will use.
Little did you know.
Right. But he and and some of the other people I work with, I guess, sort of got us off the ground on that. So we were one of the earliest. The NSSDC, the National Space Science Data Center at the time, the names changed, but same exact organization. At the time, we actually were I'm taking credit for a lot of what other people did. I had little to do with this, but these guys told NASA, you need to have like a web page, a NASA web page, and NASA, they were like, yeah, well, we don't know about blah blah. So these guys volunteered to make one. So NSSDC actually hosted the very first NASA homepage.
Right.
Yeah, and we did the Goddard homepage, and and then of course the web took off.
Yes.
And we, our little servers couldn't handle the traffic anymore, and NASA ended up taking it over in its current incarnation. But so that was another really fun thing, was sort of being there at the very beginning of the whole.
And it was an amazing beginning, because I first went on the internet in 1994, and I remember sitting around in a pub with colleagues, and everybody was saying, I think I'm going to go on the internet. Really? And it was just this sense of excitement, and what providers are we going to use, what technology do we need, and it was all this, and it was a big thing, and now somebody says, oh, I'm going on the internet, oh fine, go on,
right, why would you say that, right?
Yeah, exactly.
Dave, you've spent a fair amount of time curating these NASA websites. Your name is on a number of them, and you receive as a result, you receive letters or emails from people that find your name, you're associated with NASA, and they want to talk to NASA, so they send
lovely
all kinds of interesting things, right?
Oh, yeah. No, I get. I Lou and I, yeah, right. We've talked about these. Some of the letters. In fact, Lou, I just got one a few days ago. I will have to show you. It accuses me of being the head of groups of demons. It looks like me personally, but NASA in general, that have bases on the moon and other planets, and that we are doing all these horrible things to women and children. I won't even mention here, but it comes to me from a person who, no return address or anything, but they claim to be the leader of Mars and a bunch of other planets that I've never heard of, but obviously they must be real planets because it was in this letter.
Of course.
Get these letters over the
so I
year.
do get stuff like that. I definitely get.
Dave and I have talked about perhaps creating a book or something of letters to NASA, people who say they've solved the problem of the limiting speed of light and all of this kind of thing. So it's really quite interesting.
Oh, wow.
I mentioned this to an Uber driver one. The Uber drivers that talk to you. Oh, what do you do? What do you do? Oh, I work at, I work for NASA. I work at Goddard Space Center. You work for NASA? He goes, I have a question. You're a NASA person. I've got to ask you this question. I'm like, oh, okay, great. Yeah, I love it. Someone wants to know about space and stuff. He goes, so is the Earth flat?
Oh, no.
I went, no, it's not.
I got that question in an airport not too many years ago. When I travel, I wear my NASA pin, and oh, you're from NASA? Yes. Well, this woman said, my boyfriend thinks the Earth is flat. Is it flat? And can you help me explain to him if it's not? And so I talked to her about some of the things you would see if it was flat or if it was round, and tried to give her a little ammunition there. But it's surprising how I don't know what I want to say, but there's a certain segment of the population, I guess, that's somewhat uninformed or perhaps not informed.
Misinformed.
It's worse than that. It's something called cognitive dissonance, where basically they refuse to believe the alternative viewpoint. They just simply back themselves into a corner and won't come out.
Yeah. Well, one of the explanations I saw on YouTube, I wasn't looking for it, by the way. I wasn't looking for proof that the Earth was flat, but there was, how can I say, about a child of about 14, and he was professing that the world's flat, and as his evidence, he produced a saucer and a bottle of water. And he says, look, he said, this is what happens to water when the Earth is flat. And he poured it into the saucer. Of course, it sat there. And then he pulled out an orange and he poured the water on the orange. Of course, it all poured off. He said, if the Earth was flat, all the water would flow off. And I soon came off that channel. But it's,
and there are plenty like them out there.
Yeah, it's like Keith says, they just will not see the alternative. Some of them come up with some really bizarre explanations, and some of them almost make sense. But then you've got to step back and say, I'm being brainwashed here. Walk away quick. I'm like a goldfish. I'll soak in anything.
Well, I always say to these people, because I come up against them too, I say your explanation for the flat Earth would work absolutely perfectly if it weren't for this little thing called physics. So, but because so many of these people haven't got the first idea about physics and physical laws, they can't comprehend what you're saying. It's just, you may as well be talking Swahili, So there. Let us at this point welcome Keith and Steve. Sorry, guys, didn't say hello. Dave, these are two other space oddities, as you can probably see.
We're very odd.
Yeah, you are. Yeah. How are you, gentlemen? Are you okay?
Fine, thank you. Sorry I'm late, but I've had two other things to do before I got to this.
No problem.
Yeah. Same here. Sorry, I've come in part way through the conversation, so and I won't be able to stay on too long. But I just didn't want the day to go by without joining you all. But
well, thank you very much, because we're the countdown's on hold at the moment, as you probably know. So we're just killing time basically. And thank you to our audience for sticking with us. Very kind of you. We will, of course, be running our normal Monday evening live show at 8 p.m. UK time tonight, as usual. But we're in the dark as much as you are about exactly what's going to happen this afternoon. But everybody's got their fingers crossed, because this could turn out to be an historic day, and we hope that you will stick with us for the duration. So, how was your weekend, gentlemen? Was it okay?
Yeah.
Good.
Yeah.
Good for me. I was working at Jodrell Bank both days.
Oh, lovely.
On the Explain the team there, and it was really quite busy. I was giving the talks about the Lovell telescope that we do in the morning and the afternoon.
Right.
And Saturday afternoon, the auditorium was totally full. There must have
Was it
been
really? Fantastic
lots of
news.
people in there, which is quite remarkable. Really, really good to see.
Yeah, that's great. Yeah, I had a lovely
Right,
time at the Astronomy Ireland annual barbecue.
Oh yeah.
And talking to 600 people. That was great. That's my biggest audience ever.
Sorry to interrupt, Andy, but the launch is a scrub.
It's a
I
scrub.
just heard that too.
Due to
Yep.
an engine bleed.
Oh.
So unfortunately, we're not going to see it fly today, but we can still have a chat and talk about the future missions and things like that if people want to stay around. That's very sad. Very sad. I was quite looking forward to it now. So
yes, absolutely.
These are shuttle. These are kind of repurposed shuttle engines. Is that
That's
right?
correct.
So they've had some time in space. They've had some time to be checked out.
Yes.
They'll find the problem. They'll figure it out. As we said, space travel is hugely complex effort. Thousands and thousands of pieces of wires and electronics and all kinds of things that just have to work perfectly. So better to wait, find the problem, and
the problem may not be in the engine itself. It may be further up in the plumbing. So we don't know exactly where the problem is at the moment. So
are there job opportunities for plumbers at NASA? Perhaps that's what we
valve fitters.
Yeah, absolutely.
Valve fitters, that's what we need. So, but no, it is a shame. We did see some of these sort of like things pop up during the wet tests. Obviously, they thought they'd corrected them, but this is what it's about. It is as we were saying, this is the test flight. We've got another launch window opening on the 2nd, and presuming they don't have to detank everything, because they were talking about that they could keep the tanks topped up until the 2nd and the 3rd.
Yeah, because it's only 3 days away, isn't it?
Yeah, 3 days away. And they'll just keep them they have to keep them topped up because it boils off, because it's kept at such a low temperature. It's liquid first and it turns to gas, so they have to bleed off them, but they have to keep the tanks topped up. So we're looking at the 2nd or the 3rd. But if there is still problems after that, then there is another window later on, but I think there may be some more issues that may hinder those as well.
And for our viewers, if you tune into Space Oddities at 8 p.m. UK time tonight, hopefully we'll have some more information by then. And our intention will be to again run a live stream for the launch.
Right. 3 p.m. US East Coast.
3 p.m. East Coast. Thank you very much. Yes.
I think basically what we can talk about is why they're going to the South Pole of the moon. As I was saying earlier, it's a very cratered area, and the reasons it's cratered, when we look at the moon, when Roger takes his photographs, you see some dark areas which we call mare, which are French for seas, because they thought they were seas in the past, and then you see the lighter areas, and of course it's the lighter areas which are the older surfaces, and of course the South Pole is absolutely covered in craters. It's been peppered all over the place. As we said, it looks very, very rough. And some of these landing zones, of course, we're looking at them from quite a long distance, actually, but you've got all these craters packed in. It looks, they're going to be landing on knife edge mountains and things like that. But hopefully when they get a bit closer, they might be able to find somewhere a bit flat to land. But of course, the reason they're looking at this is there are these craters, some of them are very deep, and they haven't had sunlight in them for millions of years. And of course, this is where they know that ice does actually exist in a frozen form. I mean, Keith was mentioning the other day the Lacrosse mission, where they deliberately crashed a probe into one of these craters, and then did a spectrograph analysis of the cloud that appeared, the particle cloud,
I've made a thing for that, by the way, if you want to watch it.
So yeah, we can watch that. We'll probably use it tonight just to show what
use it
it's
tonight.
doing.
No problem. Yeah.
So
we were at DPS for that, weren't Dave? Were you Division for Planetary Sciences conference in an auditorium when El Cross?
I wasn't, but they showed it live at Goddard at the auditorium.
Okay.
I remember, Yeah,
Mm.
that was early in the morning too, if I remember correctly.
It was.
well, the moon's got to
lunchtime
be
here.
up.
Yeah.
The moon's got to be up. It's got to be dark. But but
I got to tell you something, by the way. We watched the El Cross mission on NASA TV in my school laboratory. The sixth form watched it, and we also had running some software called Celestia, and someone had made a bolt-on to show the El Cross mission. And do you know, it was in perfect time with reality.
Really?
We were
That's pretty cool.
Obviously, Newtonian physics is predictable, so fair enough. But I was amazed to see this. The animation was running perfectly in sync with the real thing.
Oh, fantastic.
Yeah.
To clarify that you were teaching A-level, not in the A-level class. I think that's
right. He was a late developer, Steve. Jolly good. Well, guys, if you don't mind, I'm going to leave you because if we're going live later, I've been up since 4 and I want to go and get at least a few hours sleep before we tackle the program this evening. So, Dave, it's been utterly so good to meet you, and thank you so much for being with us today. And sorry we didn't get a good result, but there's always next time. And if you can join us next time, we'd love to have you. So.
All right. No, thank you. That was great. It's great joining you guys too. Thank you so much for inviting me. And I will. I'm actually leaving for Italy today.
Right.
But Lou can keep in touch with me, and it's possible I could do it from there.
That'd be great. That'd be fantastic.
We'd love to have you join us if you can make it.
Yeah. Some
Are you
the second or the third?
Yeah. Yes.
Okay.
Yeah. Is it work you're going to Italy for, or pleasure?
It's okay. Well, there's a much longer story, but it's vacation. It's complete vacation.
Oh,
this
fantastic.
is where my wife and I started our romance, whatever you want to call it.
Oh, lovely.
6 years ago. So we're going back for that. But I am actually bringing some moon tree seeds because they want to plant them at a couple places, including the University of Padua, which is celebrating its 800th anniversary this year.
Right.
And just because I never get to do this, I'll name drop, but we're going to visit Brother Guy Consimano, the Vatican astronomer.
Yeah, fantastic.
Yeah.
That'll be good.
Bringing him some moon tree seeds because they want to plant them at the Vatican Observatory, and he's going to show us around. And he was like a colleague of mine, but I've never met him personally. So anyway, so I'm pretty excited about that.
Well, have a wonderful time.
Yeah, and watch out for the Illuminati
and safe travels. And I hope you don't have a screaming kid for hours behind you in the seat like I did this morning. All right. See you later, everybody. See you for the live
cheers,
show.
Andy. See you later.
Take care. Bye-bye. All. Bye-bye.
Right. Has anyone got anything they would like to talk about as regards the SLS, which unfortunately is been scrubbed now, unfortunately.
I was just going to say.
I'll mention one thing that you guys may not know about that this. Oh, I'm sorry. Were you?
No, you go ahead, Dave. You go ahead.
Okay. I'm sorry. No, I just. There are actually 5 Cubesats that are running purely on battery and cannot be recharged.
Mm-hmm.
And as the mission was delayed, they're getting more and more worried. Some more than others. I guess some of them aren't so worried about the battery power. Some of them can be recharged once they get in sunlight, but apparently, there's 5 of them, and a few of them at least are a little nervous about if the batteries are still going to have anything in them when they finally get to space. And so I don't know. Another launch delay is critical for them. But anyway, I just wanted to bring that up.
Yeah, because they were mounted into the rocket quite a long time ago. Right. And once they were mounted, they can't get access to them. So yes, as you said, they are a bit concerned that whether or not the batteries will last. And as I said before, it was also this is a problem with the self-destruct mechanism. They have to, after I think it's 20 days, they have to retest it and make sure everything's working again. But the I think it's the army who actually supply the destruction explosive thing. They've said that they can extend it to 25 days. So of course, and this is what I was saying, that if it misses this window, and it has to be taken back to, will have to be taken back to the vehicle assembly building. With that having to happen, because again, it's something that can only be accessed while it's in the VAB, that it could actually miss the following window because of all the work that will have to be done to re-prepare it and things like that. But fingers crossed, we will get this thing up and flying in a few days' time. We don't want to be negative. Let's be positive.
I was thinking a few minutes ago that you only have to look at the James Webb Space Telescope to see how patient, resilient, determined all those involved in the project have to be, probably in the face of enormous pressures. But at the end of all that, they got it absolutely right.
Spot on.
Take any unwarranted chances, and that's the way it has to be, isn't it?
Yeah, it really is. What do you think of the James Webb images, Dave? Do you are you fascinated like we are about them?
Oh, absolutely. Oh, right. And not, it's not my field, the astrophysics.
Yeah.
Although I've seen already, I guess, one of Jupiter, right? And I'm expecting more, more planetary images too, which I'm particularly interested in. But the pictures were unbelievable. I mean, I was riveted, when they were releasing the pictures. I was riveted, probably just like you all were. That it's unbelievable. I mean, people talk about how expensive it is and stuff, and I'm just kind of telling them, I'm not an astrophysicist, but this is going to change the way we look at the universe. I guarantee whatever we learn, it will not be what we expected, and it'll be a surprise, and it's going to, throw out a whole bunch of ideas that we thought we understood, and once they really
already
back,
is.
Right. And already has, right. I mean, it took like no time, and I can't even imagine when they really, they start looking back to like just so early in the universe. I can't even imagine. But anyway, I'm fascinated on every level. Just looking at these beautiful pictures and also the science. So.
Yeah, it is fantastic. I mean, what we've seen, as you say, it's caused a bit of controversy already. As regards possibly the age of the universe, but this is what we're doing it for. It's to we've got a theory. If it's wrong, we need to adapt it and understand why it's wrong. I mean, the early spiral galaxies that they're seeing, which shouldn't be there, are causing confusion, and they're smooth. They're not regular. They haven't been bashed around by interactions with other galaxies. But this is what it is all about. And of course, they've already looked at the TRAPPIST system, and they found carbon dioxide in the atmosphere of one of the planets out there. I can't remember which one. But yeah, it's absolutely fascinating. Sorry, Lou?
The first, its designation is B.
B. Oh, so it's the first one then.
First one discovered.
Yeah, it's the first one discovered. So yes, it's and this is what it's all about. This is what science is about. Is you adapt theories and then you try to test them. And if it does turn out the summit later on says it's wrong, let's go back and have a look again and reassess everything. And this is what it's about. It's the scientific method. But I mean, the images have been stunning, and also what is fantastic about it is that the data is available to astrophotographers to do their own images, and some of the images that these people are coming out with are absolutely fantastic. So it's involving people as well, and of course we've said before, with all the other telescopes and the probes, Gaia and things like that, and what's coming up with the Vera Rubin. The data that's got to be trawled through, you're going to have to involve more and more citizen science, and people will be able to get involved. And it's like Zooniverse when it first came out. You were probably the first person to see that galaxy in front of you, to actually look at that galaxy. And you're actually part of the community. You're actually doing science for people and that. So it's a very exciting time to be living in. So sorry, I'm a bit of a. I love Zoom. I love data science,
You're right,
citizen science, and that. So.
I think it's incredible that say the Webb is looking so far back in time, yet the universe as we know it is all already there, even after such a short space after what we believe to be the Big Bang. That it has evolved to such an extent, it didn't waste any time in getting going. Which is quite phenomenal.
Yeah,
well, they say that science marches slowly, step by step, but when we have major technological advancements like linear accelerators, like the transistor, like the laser, like then like James Webb, then science advances in leaps and bounds. So I think we're seeing that nice pairing between technology and science understanding.
Yeah,
Dave?
I still remember when I was in graduate school, and I guess Voyager was on its way to Saturn. Maybe it was undergraduate. I don't remember. Anyway, it doesn't matter. At the time, they had the rings of Saturn all figured out, right? I mean, I remember that, oh yeah, we understand the rings of Saturn, blah, 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 blah. And the first images came back from Voyager. And I mean, within a day, everyone knew they were completely wrong, and they had to redo their entire dynamical. And I feel like that similar levels of that happen almost all the time with these kind of things. Like you say, when you make a technological advance, so something like a Voyager finally gets to Saturn and gets a really good pictures. All of a sudden, either things go out the window. Things are confirmed too. I mean, it's not like everything just goes out the window. I mean, certainly everyone remembers like Kobe, right? When they showed the beautiful, the
microwave background,
basically the curve, the curve that showed the Big Bang and the warming and all that was one of those things where they said, oh wow, okay, we were right, So, but it's wonderful to see this. It's wonderful to be living at a time when you see this, I think.
Dave, I have a wonderful picture of Lonnie Lane, who I think was the PI of the photopolarimeter experiment.
Yeah.
And with looking at sheets of paper with about 10 people around him looking at this paper. And this was an experiment, a stellar occultation experiment for the rings of Saturn. So Voyager looked through the rings of Saturn at a star. And as the spacecraft moved, it tracked the star through the rings. And of course, when there was ring material, the light from the star dimmed. And when there was no ring material, it was bright and so on. So they had this very jaggedy set of lines, which seems like something nobody would be interested in. But here are 10 people crowded around this piece of paper, looking at the very fine structure of the rings of Saturn, absolutely fascinated, absolutely thrilled that this is some of the first data of its kind coming back from anywhere, but certainly coming back from Voyager. It's just a wonderful picture of how exciting and passionate people are, scientists are, when they have an opportunity to look a bit further. Anyhow, it's a cool picture.
Yeah, because of course what we've got to also remember is back in sort of like 1900, it wasn't really till 1920 that we really started to understand the universe. We had stellar nebula, which were stellar islands, star islands as they called them, or nebulae, which of course then turned out to be galaxies outside our Milky Way, because everybody thought the Milky Way was the universe. And since then, we've marched on slower and slower and slower. I mean, they thought Venus, underneath the clouds of Venus, there was tropical forests, but then it turned out to be hell. And the same with the moon. It was all thought to be spiky mountains and pillars and things like that. And when you saw the images, but then it turns out that it has mountains, but they're all smooth and things like that. Because I mean, as we said, the dark areas are the new surfaces, and the light areas are the old surfaces, which we found out through exploration. And as we march on, it's really Lou's got the planets.
This is a book that I got when I was very young. My aunt and uncle would send me one of these life science library books for Christmas each year. 1967. And here are some possibilities for what the surface of Venus looks like back in 1967. Forest, an oily ocean. Here's the tropical forest. This is what we knew or imagined just not that many years ago in terms of the history of human time. But I go back to this book all the time to remind myself of how much we've learned in such a very short period of time about the universe.
I was going to say that we enthusiasts of a certain age have lived through the entire space age and seen everything, every development that it's had to offer. Apollo, Voyager. I think Voyager was, I've said it before, possibly the most extraordinary revelation of all, because it just opened our eyes to our own solar system in a totally new way, and really got everything else going, I think, for exploration.
Yeah, exactly. I mean, we like you said, we are the space age children. I think the only thing I missed is when they sent Laika up, and the dog, the Russian space dog. I missed that by a few months or a year at the most. But since then, that's what I've been driven by. Is and as I said, we were sorry, I've just got a message. So yeah, the Apollo era, and because I can always remember when, like Andy asked Dave, I can always remember when I was about 3 or 4, standing in the New Forest in the south of England. It was a guides jamboree thing, because my mum was the guide leader, and I can remember standing in there in perfect pitch blackness and seeing my first satellite go over, and it was absolutely, just blew me mind. I thought, I don't think I could really understand what's a satellite, since then. And of course, in that era, those days, when dinosaurs roamed the earth, we didn't have the light pollution like we do now. And I lived in a market town in Wiltshire, and the only street lights we had were in the centre of town. So as soon as you left town, you had the skies over, and I can always remember my mum pointing out the Pleiades and Ryan and things like that. But then in those days, it was so hard to see them because there were so many stars. And it's something that we really must get somewhere back towards that. But yeah, it's we are sort of like, as you said, the space race children, and the Apollo children. But now we're entering a new era of Artemis. So hopefully,
forgive me, Dad, but back then there probably wouldn't have been that many satellites up there.
No, there wasn't. That was the thing.
It would have been a really very rare, extra special sight to have seen one.
Yeah, that was exactly it. I mean, now I put my camera out, 10-second shot, and I've probably got about 6 or 7 satellites in the shot. Anything, if you go for a really long exposure, it's like rush hour up there.
Dave, what is NASA doing about this problem? Can you share that with us?
The problem of too many satellites, is that your problem?
Yeah, Starlink and all of this.
Actually, I think by far the majority of the satellites by far are commercial. Communication satellites probably dominate the number of satellites, but I don't think working satellites are really the problem, right? The real problem is defunct or busted up satellites.
And of course there's
that's
a problem.
Not a trivial problem at all.
Yeah, I mean, of course the problem is people say, oh, we need to deorbit these satellites and all in that. But the thing is, it's not that straightforward. You could send things up and you can push them back into the next thing you're facing a lawsuit, because that still belongs to somebody, and that company may not exist as it did. but you know, it's been bought out several times and all that, but that still belongs to that original company, and you have to get permissions and other things like that. And of course, you don't want to go tampering with any of the military satellites, because they're not going to be too pleased if you start bringing down their satellites.
Their spacecraft, because they want to have the best high resolution images. Their satellites generally, I think, I hope I'm not giving away any secrets, fairly low altitude. So they'll deorbit on their own pretty quickly, I suspect. But I cut my teeth, so to speak, when I was an undergraduate, doing some geopotential modeling, and there was just a piece of space shrapnel, a rocket that had blown up, and this piece of it was orbiting the Earth, and I had to track it and figure out what its orbit was. And so there's a lot of this space junk out there that's not just a satellite that's not working anymore. It's just junk from collisions, explosions, and all kinds of things.
Yeah.
Hi guys. Hi.
Oh, sorry. Yeah,
sorry, Dad. Yeah, I just wanted to say that on my latest research on new space organizations based in Europe, quite a few of them have this ambitious goal of trying to create this circular economy, whereas they want to try and reappropriate satellites that are just not being used anymore and try to see whether they can recycle them. And I know, it's extremely difficult and complicated, but there's a lot of assets out there that are just not being used anymore for various reasons. And they're also trying to push so that the new satellites being created are more and more modular, so that in the future you can start to sort of take them out piece by piece and reuse them for whatever has been working or not. So I think this might be a problem now for us, but maybe in 50 years, of course, the number of satellites is still going to be growing, but hopefully, by then the satellites will be able to be reusable in one way or another, which might potentially start to reduce this pollution issue.
Yeah, because the British space industry, they're really big on retrieval or deorbiting. They're working a lot towards it, but we've got to sort out the law side of it, because the law for space is a bit loose, a bit wish-washy. It's more you can abide by it if you want to. You don't have to sign up, but it can cause problems later. You can't just go up and, like I say, deorbit somebody's satellite because it's defunct. But as Lou says, a lot of them will eventually deorbit themselves. But the rate that they're putting them up there, it will become a problem, especially if we start having some collisions, which we've experienced as well. Because I think Keith was on about them a couple of months ago on the show, and I've spoken about them, about these Russian rockets, SOS engines.
SOS, yeah. Ullage rockets, yeah.
Ullage, that's it, Ullage rocket, which they've been up there, and I think there's probably at least 10 more to come down. But what they do is eventually they actually explode, producing more space debris. So I think they put something. I think I'm off the top of my head, I think it was about 40, and there's still about 10 to come back to do what they're going to do. And so yes, as Lou said, it's just all space debris. It's a state of affairs that needs to be corrected. Also light pollution, if we can get that a bit more selected. I mean, I'm quite lucky because although I've got street lights just outside on the little estate I'm on, they turn off at midnight. They are quite hooded, but with what I've got around me, I'm sort of like about 3 or 4 on the scale of light pollution. So it's a sad state of affairs, but hopefully eventually people will come round, because we have actually got in Parliament our own dark skies department. I did sign up for a newsletter when it was formed about 3 or 4 years ago, and I've heard nothing. I know we've had the pandemic and things like that. So if they're actually doing anything, I don't know. but they set up a committee to look into this. Maybe somebody's working in the background, but yeah. Anyway, I'm waffling. Anybody else?
Yeah, I was going to say with the dark skies thing, it's all about money at the end of the day. If you can sell dark skies tourism, then all of a sudden everyone's interested in turning the lights off. And there's a small town in mid Wales called Prestine where they've actually taken quite significant steps to reduce the light pollution there.
Yeah, that's just down the road from me. So yeah, it's
so it can do that. By the way, just changing the subject briefly, you can see behind me, right? It's a picture I took out of an airline cockpit about 20 years ago. And I put a red line on it, as you can see, and you can see that the Earth is curved.
Oh, I don't know about that. I think it's probably your lens. I think that was your lens. It's an aberration.
No,
I don't believe that.
Knew that. Yeah, I knew you'd come up with that one. Well, it was taken with a standard lens that doesn't have barrel distortion. So I assure you it's genuine.
We believe
controversy.
you.
Controversy.
Guys, I just wanted to drop in and say hello, and unfortunately the launch was scrubbed, but I'm gonna go and do some kiting with my daughter now, my 7-year-old daughter.
Oh, sweet.
That sounds like a good
the weather's nice, and I'm gonna try and infuse this love of flight and aeronautics to her. So wish you guys luck, and I think it's moved to the 2nd of September. Is that correct?
Yes, second, and there's probably possibly of the 3rd as well, but we will have to wait and see. It is such a shame. I was looking forward to this. I mean, I've stayed up all night sorting all this out and sorting the watching the fueling and things like that. And
Sure.
But there's been ups and downs where they sort of like had these leaks and they think, oh no, they're going to scrub. Oh no, they were working around it. So it was a bit of a troll, but yeah, it was fun anyway. And I'll have to do it again.
We'll have to, as they always say, space is hard. So there we go.
And we're dedicated.
Have fun with your daughter, Bernard.
Thanks. Take care, guys.
All right. Dave, I know you have some travel plans today. Are we going to stay on for a little longer, Des?
Well, if people want to talk, they can do. But what I'm going to probably do is I'm going to stop the YouTube feed for now. We've still got 11 people watching, but and then we will reassess our options and see what we can do for the 2nd and the 3rd. And hopefully, if everybody joins us tonight at 8 p.m. UK time or 3 o'clock EDT,
thank you, Des.
Then we will hopefully have some more news, and we'll be able to fill in what's actually gone wrong. So if everybody's happy, we can stay on the Zoom for a little while. I won't turn it off at the moment, and I'll just stop the YouTube link. But thank you everybody for watching and staying with us, and I hopefully will see you tonight. If you have any questions for tonight, don't forget, log on and put them in the chat, and we will endeavor to answer them. If we can, we will find out for you. There's no problem at all. So I'd like to thank the panel as well for being here, and hopefully we'll see you all at 8 o'clock tonight. So if everybody like to say goodbye, bye YouTube, bye. And don't forget to hit the likes and subscribe and the notification buttons, because it all helps us, and we can be able to do more with it. So okay then, everybody, thank you again for being with us, and we'll see you again hopefully later tonight.
Cheers.
Right. Thank you. Yeah, Lou's right. I'm going to get a few more things to go before I leave, and I guess I'll be at the airport by the time you're talking tonight. So